on page 13 of your DIO workbook, you've got a practice calculation to do, and this video will take you through each step on how to do those calculations. The first set of calculations you need to do is to work out the volume used for each of these titers. Firstly for the rough, and then for your first accurate titration, followed by the second and third. To do these calculations, you take the final reading, 22.30, and subtract off the initial reading, 0.80, and your answer there, 21.50, will go here into the table. Remember, you must record your value with 2 decimal places for excellence. Once you've recorded your 21.50, you're on to the next volume. So again, take the final reading, 42.95, and subtract off the initial reading, 22.30, and this answer, 20.65, will go into this box. Pause the video and do the second and third ones. Assuming you've done your calculations correct, these are the values you'll have for the titers used. Moving to the next step, we need to now find the average titer. You are going to be instructed each along the way. So excuse the numbering because it is like that would normally be number 1, but we'll go with the sequential numbers. They actually match up with your worksheet. So here you can see it instructs you to only average the concordant readings, and those are the titers that fall within a range of 0.3 mils of each other. So you can see that the titers 1, 2 and 3 are all within a range. It's actually it's smaller than 0.3, which is good. But this 21.50 is considerably bigger. It's 0.95 bigger than your smallest value. That one will be excluded and not used when you are doing the average. Show your working and show which 3 values you have averaged, or if you are averaging 4, show the 4 values you average. So I've taken these 3 values and divided by 3 because there are 3 values. This gives me the average of 20.60 mils. Remember, you must record your value with units, and in the case of burette readings, always to 2 decimal places. It's good practice, because you won't get told to do so, to convert the volume now into litres, and to do that you divide by 1000. The next question on the worksheet, number 6, tells us to use the average titer. Note that we'll be using this one here in litres. And they tell us to use the known concentration of potassium hydroxide, which is given here in brackets. And they want us to calculate the amount. So you will now need to recall that the amount is concentration times volume. You are, and I'll just go back one slide, you are given concentration equals the amount divided by volume, but you will need to be able to rearrange that and come up with the amount is therefore C times V. I'm a big fan of the triangles, and they are on the walls in our classrooms, which you can use. So this is the working. To calculate the amount, it is the concentration times the volume. we are using the concentration provided, and we're using the volume of the potassium hydroxide, which is the average of the titer values. Remember, the potassium hydroxide was in the burette. Your calculator will actually give you a value of 0.002266. It is good practice to record your answer to 3 significant figures with units. It's also good practice, but not entirely necessary, therefore not required for excellence, to give an answer in standard form. I am happy for you to keep it in this decimal value if that is what you're comfortable with. Moving along to question 7, it asks or tells us to use the balanced equation for the reaction in the titration. So this equation shows 1 mole of potassium hydroxide reacts with 1 mole of hydrochloric acid. The mole ratio is 1:1. So what that means is that the amount of hydrochloric acid is the same as the amount of potassium hydroxide. It's 1:1 ratio. It's the same amount. And then you're into the last calculation on this worksheet. It's numbered 8. And they're asking us now to calculate the concentration of the hydrochloric acid. To do that, you've got the amount, and where you'll find it perhaps slightly tricky is they don't tell you the volume of the hydrochloric acid. If you go back to the very beginning of the worksheet at the very top, it tells you they used a 25 ml pipette with the hydrochloric acid. So the volume for the hydrochloric acid is 25 mils. So now if we substitute in those values, remember we're using the full number, not the rounded number that we've written in 6 and 7. Just ignore that 2 and 3, that should be 6 and 7. And we're dividing by the volume of the pipette, which was 25 mils, but it again must be in litres. And there you go, there is your final answer. All titration calculations follow a very similar format. This is the format that you'll be getting for your assessment. You can now move on to page 15 in your workbook, where there is a further practice titration calculation to complete.